We can draw Lewis structures by following just a few simple steps. The first step is to draw the connectivity of the atoms. So for example, if we wanted to draw the connectivity as CF4, we would put carbon in the middle, we would put fluorines around on each side, and they would be connected by a straight line, like this. You can never have hydrogen as a central atom, because hydrogen can never have more than one bond. Normally, the least electronegative atom is the one that will be in the center. Next, you want to count the valence electrons for all the atoms. In this case, carbon has 4 valence electrons, fluorine has 7 valence electrons. There are 4 fluorines, so that would be a total of 28 valence electrons for fluorine and 4 valence electrons for carbon. So that's a total of 32 valence electrons for this molecule. Next, we're going to subtract the number of electrons that we used during bonding. Each of the lines represents 2 electrons, so we're going to subtract those from the 32 valence electrons. The third step is going to be to distribute the remaining electrons around the outer atoms. For this molecule, we have 24 electrons remaining, and so we're going to have to distribute them evenly around the fluorine atoms. And so we're going to do that by putting 6 dots around each fluorine, and each dot represents 1 electron, and so we're going to have 3 pairs of dots, 3 lone pairs of electrons around each fluorine. Next, we will take inventory of how many electrons we have remaining. So we used all 24 of those, and so we have no electrons remaining after we have distributed all the remaining electrons. Now, at this point, our Lewis structure for the CF4 molecule is finished. Since we have, we can check to make sure that we have all atoms with an octet, which they do. We see the fluorines each have 8 electrons around them. Each carbon has 8 electrons around it as well. So this Lewis structure is now finished. Now suppose we had a Lewis structure where things didn't work out quite so nicely. Suppose we had one where we had electrons left over after we had distributed all the remaining electrons. An example might be something like the ammonia molecule, NH3. For this one, we have nitrogen, which has 5 valence electrons, hydrogen, which has 1 valence electron. There are 3 of those, so that's 3 valence electrons, for a total of 8 valence electrons. There are 3 lines connecting the nitrogens to the hydrogens, so that is a total of 6 electrons used in bonding, and so we will subtract those from the total of 8, and that leaves 2 electrons remaining. What to do with those 2 electrons? Okay, those 2 electrons are going to be put as lone pairs on the central atom. So the remaining electrons, after we have distributed electrons around the outer atoms, remaining electrons can be placed around the central atom. Another possibility when drawing Lewis structures is that we may not have enough electrons to give all the atoms an octet. In the formaldehyde molecule, CH2O, we have a total of 12 valence electrons. We will use 6 of those valence electrons for bonding, and that will leave a balance of 6 electrons remaining. And those 6 electrons can be placed around the outer atoms, which is the next step. And so we'll put those around the oxygen. But notice that carbon does not have an octet now. And we don't have enough electrons remaining to give carbon an octet. And so what do we do in this case? Well, in this case, what we're going to do is form a double bond by moving a pair of electrons from the oxygen down into the bond between the carbon and the oxygen, so that we give a double bond between the oxygen and the carbon, like this. You can see now that each of the atoms now has an octet. Hydrogen doesn't have an octet, but it doesn't need one. Oxygen has 8 electrons around it. Carbon has 8 electrons around it. This Lewis structure is now finished. So far, we've looked at molecules that have 4 or fewer atoms around a central atom. What if we're given a molecule that has more than 4 atoms around a central atom? Is it possible for the central atom to have more than an octet of electrons around it? And the answer is yes, it is possible. For elements below the second row, you can place 8, 10, 12, even more electrons around them if you need to. An example would be something like sulfur hexafluoride, SF6. When you draw that one, you see that sulfur has 6 fluorines around it. And these 6 fluorines, just without placing any additional electrons, are going to give sulfur 6 bonds. And so this has that means at least 12 electrons around sulfur. So yes, it's possible for those atoms below the second row to have more than an octet around them. So for SF6, we will count the valence electrons. Sulfur has 6, fluorine has 7. There are 6 of those, so that's a total of 42. And now we have a total of 48 for the molecule. How many electrons did we use in bonding? Well, we drew 6 lines, so 6 times 2 is 12 electrons used in bonding. And so we subtract those from the 48, and we have 36 electrons remaining. Those electrons can be distributed around the outer atoms to give them an octet, so each fluorine will get 6 electrons. And once we've distributed all 6 of those, we have just used up our 36 remaining electrons, and we have none left. And so this Lewis structure for SF6 is now finished.